Let us solve few questions here. The electric field line inside a uniformly charged spheric shell. See, now uniformly charged spherical shell, electric field inside a uniformly charged spherical shell is. Obviously, it is a 0. Just now we have done, right? What it is? It is 0. Why? According to Gauss law, a spherical shell with uniformly charge distributed on its surface, the electric field inside the shell is 0. Because जो बाहर जाएगा वो अंदर जाएगा, एक दूसरे को कट कर देंगे, तो अंदर तो कुछ होगा ही ना. There is no charge enclosed within the surface, so EDA is 0. Figure shows 3 point. Question को ध्यान से पढ़िए. 3 point है +2q, -q and +3q. 2 चार्जेस हैं +2q एंड -q आर. 2 चार्जेस को अंदर किया गया है सरफेस के. व्हाट इज द इलेक्ट्रिक फ्लक्स ड्यू टू द कन्फिगरेशन? सो आपको इलेक्ट्रिक फ्लक्स कैलकुलेट करना है. ट्राई टू डू इट बाय योरसेल्फ. यस, समझ में आ रहा है कैसे इलेक्ट्रिक फ्लक्स निकलेगा? 2 चार्ज अंदर है +2q -q और एक बाहर है. व्हाट यू हैव टू कैलकुलेट? यू हैव टू कैलकुलेट द इलेक्ट्रिक फ्लक्स, right? So electric flux basically inside the surface is represented by integral like this, E dot ds for a small area element. So according to Gauss law, electric flux is equal to q by epsilon naught only, right? So now you have charges within the surface. अंदर कितना चार्ज है? +2q and -q. So the total charge +2q -q by epsilon naught. So what is the flux? Q by epsilon naught. 5q by epsilon naught will be the answer. Why we are not talking about this? Why we are not taking +3q? Because it is outside, na? We are talking about a closed surface. Gauss's law is based due to closed surface के अंदर जो charges है ना, उनके लिए यहाँ बात हो रही है. बाहर जो भी है हमें मतलब नहीं है. So inside we have 2 charges and we can calculate the flux through it. So flux is actually q by epsilon naught. Q total by epsilon naught, so +2q -q by epsilon naught. 2 charges of magnitude -3q and +2q are located, right, at point A0 and 4A0. What is the electric flux due to these charges through a sphere of radius 5a with its center at the origin? So what is given here? 2 charges given, q1 -3q, q2 +2q located at point A and 4A. What is the electric flux due to these charges? Now what you have to calculate the electric flux. So suppose here you have a sphere. At point A you have -3q, at point 4A you have +2q. Okay, electric flux is charge enclosed by epsilon naught. How much charge enclosed? +2 - 3 epsilon naught. So -q by epsilon naught is the charge. That point is given only to confuse, only to get you confused, right? Again another question. Try to solve. A charge q is placed at the center of cube of side L. Okay, what is the electric flux passing through each face of the cube? What is the electric flux passing through each face of the cube? अगेन एक चार्ज Q है, क्यूब के सेंटर में है जिसका साइड L है. इलेक्ट्रिक फ्लक्स ऑब्वियसली 1/6 phi E, so it is Q by 6 epsilon naught. We have already, like starting में ही we have understood this example. Okay. Another question. A hemispherical bowl of radius r, a hemispherical bowl of radius r is placed in a region of space with a uniform electric field E. Find out the electric flux through the bowl. A hemispherical bowl of radius small r is placed in a region of space with a uniform electric field. Find out the electric flux through the bowl. So the surface area of the hemisphere is 2 pi r. Sphere का surface area 4 pi r square, right? So hemisphere का surface area 2 pi r square. The filled lines are parallel. The axis of the plane of the ball is theta is equal to 0 डिग्री, राइट. अभी जो फिल्ड लाइन होगी, यहाँ से जो फिल्ड लाइंस निकलेगी, दे आर पैरेलल ओनली ना, एंड इफ दे आर पैरेलल लाइंस, फिल्ड लाइंस, देन व्हाट हैपन, 0 डिग्री एंगल. सो इलेक्ट्रिक फ्लक्स इज इक्वल टू ई डी ए कॉस थीटा, थीटा 0 डिग्री, कॉस 0 डिग्री 1. सो ई 2 पाई आर स्क्वायर विल बी द आंसर. ओके, सो द फिल्ड लाइंस बेसिकली बोल के पैरेलल जा रही हैं, सिंस इट इज अ हेमिस्फीयर. So all the field lines, the angle between the bowl is, between them is 0 degree. All are right. Angle is what? Basically जो field lines होंगी, right? Angle is 0. Spherical conductor has charge Q. The electric field just outside the surface of the conductor. Now what is the electric field outside the surface of the conductor? It is, just now we have calculated Q by 4 pi epsilon naught r square. Outside the sphere के लिए यही electric field हमने calculate किया था. In your exam you may get direct numerical only. Okay, they will give you the values and they will ask you the answer. You are given electric field line of force as shown. At what point is electric field minimum? किस point पे electric field minimum होंगी? At what point the electric field is minimum? A, B and C. C, जहाँ पे इलेक्ट्रिक फील्ड लाइंस मोर होती हैं, बहुत ज्यादा कंडेंस होती हैं, वेयर यू हैव मोर इंटेंसिटी, ठीक है, यहाँ इलेक्ट्रिक फील्ड लाइंस कम दिख रही हैं, तो फोर्स भी यहाँ पे कम होगा. सो यू हैव अ मिनिमम फोर्स एट पॉइंट बी, राइट. A and C you have a maximum force. Infinite line charge, linear charge density lambda is given 5 microcoulomb per meter. Find the electric field at point 2 meter away from the line. So it is a linear charge density. So L is given 2 meter. What is the electric field due to linear charge density? Remember we have calculated E is equal to, like dE is equal to what? Lambda dq by dl. This is only we have learned ना. So अब इसको फॉर्मूले में रख दो. For whole field E is equal to 2 pi epsilon naught r, right? And then just put the formula and you will get the value 4.5 into 10 to the power 3. So just try to practice these by your own also. Okay. Spherical cell of radius 0.5 meter carry a total charge of 10 to the power minus 6 coulomb. Calculate the electric field at 1 meter from the center. तो सेंटर से 1 मीटर पे आपको इलेक्ट्रिक फील्ड कैलकुलेट करना है. सिंपली द सेम फॉर्मूला, E is equal to Q by 4 pi epsilon naught r square. Value is given and you can able to solve the question. A uniformly charged infinite plane has its surface charge density sigma. Find the electric field. तो अगेन आपको surface charge density दिया गया है, आपको सिग्मा निकालना है. अगेन अगर फॉर्मूला याद होगा तो you are able to solve the question. What is surface charge density? How you are going to calculate? Sigma by 2 epsilon naught. So E is equal to sigma by 2 epsilon naught. Value is given. Just put it into the formula. Right? So with this, we are ending up this session and we are ending up electric field and charges. Now we'll continue with electric potential, right? Electricity, electric potential and capacitance we have to start. Now next topic. But before that, प्लीज ट्राई टू सॉल्व क्वेश्चन. बहुत इंपॉर्टेंट है. गॉस लॉ एंड उनके एप्लीकेशंस पे न्यूमेरिकल्स इसी तरह से पूछे जाएंगे. सो जस्ट ट्राई टू प्रैक्टिस मोर एंड मोर. कॉन्सेप्ट समझ में आ गया है. अब जितना क्वेश्चन प्रैक्टिस करेंगे ना उतना ज्यादा क्लियर होगा.
अब एग्जाम की तैयारी को और बेहतर करने के लिए हमारे चैनल को लाइक, शेयर और सब्सक्राइब करना ना भूलें.